my API key, so 1 second, just grab that. Here's what I made earlier. And then okay, so if I execute this, hopefully we'll get posts on Google Plus talking about Odessa added to the end. And as you can see, people have already started talking about me in the audience. And if you click on the image, you can see that the images have been, oh, someone's overposted a picture of me there. Great, okay, cool. So it's working, it's live, real-time results coming from Google Plus into your web page, which is very, very cool. So it's a great way to integrate social and really enhance your application in that sense. Okay. Yes, obviously you can make it look a lot prettier than I did. I really go to town in the CSS and the design and make it a lot more useful. But this is, in essence, some of the things you can do. As you mentioned, there is another way to do cross-site data fetching, which is using cores. Now, the reason I didn't go into this example is that at the moment it requires some non-trivial server-side logic in order to inspect the headers and return the appropriate responses, which, depending on your infrastructure, can be tricky to set up. Not all browsers support the new XML HTTP request object yet.
Google does not support those browsers.
Huh?
Google does not support those browsers.
Sure. I mean, I'm talking in general for everyone's applications, not just Google, but yes. And of course, authenticated cores, so if you're using authentication, is a pain in Internet Explorer. So if you can use cores and you use it, it's much more robust and it's been designed from the ground up to access content from different sites. If not, use JSONP and just make sure you trust the site you're taking data from. Otherwise, a malicious user can inject bad JavaScript and take your cookies and your login details or something, so that's not good. Sorry? Right, this as well, yes. But that's public, so it's okay. And if you want to learn more about cores, there's a great article on HTML5 rocks linked in this slide, which you can read in your own leisure. It's massive, so it's quite a beast instantly. So we're going to touch on high-performance coding. So I know there's some advanced developers in the room. Hopefully this might be of interest to you guys. First of all, has anyone heard of request animation frame? Okay, cool. A few people. So in the past, people, when you make animations, would use set timeout, and they'd specify here every 17 milliseconds I want to call this function and do update the animation. This is bad because on slow computers, you're going to start getting really slow performance because you can't handle that speed of rendering the animation. Now, with request animation frame, the browser tells you when it's ready to render the next frame in the animation. So you're working with the browser. And this piece of code here basically checks for an instance of request animation frame. If it doesn't exist, we're going to fall back to a set timeout at 60 frames a second. But that's like the worst case scenario. If you can use request animation frame, try and use it. And how do we use it? Just quickly scroll down. So here's a typical animation. Oh, there's a question over there. Or no, okay. Here's a typical animation loop. One extra thing to note here is that we pass a variable called time here. So when request animation frame calls your function, it's going to pass you the timestamp of when it called you. And this allows you to keep the right pace of your animation, because it might call you in 30 milliseconds, it might call you in 60 milliseconds. So in order to keep the frames correct and in order, you want to know when the timestamp was, so you can calculate what frame to render next. Okay? And then basically, if we don't want to stop our animation, we simply call request animation frame, the name of the function we want to call, and then this magical property called optional element. And what this does is if you specify the DOM element you're rendering the animation into, you pass it here. If that's not visible on the page, it's not going to call you. until it becomes visible. So your animation effectively pauses when the content isn't visible on the page. And that's really useful because while you're rendering stuff and no one's looking at it, there's no point. So save the processing cycle, save the battery life, and use that optional element right there. Any questions on that? No? Okay. No? The next thing I want to just touch on is that not all loops in JavaScript are born equal. So some of you might prefer to use for loops or while loops, or maybe even do while loop being that way. But basically, on your browsers, the performance, before you even added any code into these loops, is drastically different. You can see here, for example, on Firefox, a while reversed simple loop has many more operations per second than the traditional for loop, which is only at 22,000. So if you're really trying to squeeze every ounce of performance out of your application, maybe for a particularly complex animation, use the right loop to begin with. And it can vary from browser to browser, and with time things might change, but if you know you're targeting a specific browser, then take advantage of this kind of data to use the right loop from the outset. And there's a JS perf in the bottom of the slide which allows you to try this in your browser for yourself. You can see the performance on your computer.
I have a question. Why Chrome is so slow?
Unfortunately, I'm not on the Chrome team, but I can't.
No, I mean, compared to Safari, they're using basically the same.
It was launched on an Android phone.
So I don't have the answer to that, but yes, I shall pass that feedback and tell them off when I get back. But as I said, this can change with time. These results, I don't know when they were taken exactly. If you click on the link, it will tell you the details of the dates when these were recorded. Things may be better by now than that. The next thing, so efficient looping. I love my looping. So basically, typically when you write a while loop, you might do something like this. You have an array, you go var x equals 0, whilst x is less than the array length, do something, and then you increment x. Now this isn't very efficient because every time in that loop, you're looking up data.length, and that actually can add up to be a non-trivial amount of time to do that every time. So the better way to do this is to cache the data length in a variable beforehand, and then go, well, x is less than length. And this time we're not looking it up every time. So if you've got a particularly complex object, you're not having to go down the chain and finding the variable and then comparing it. So that would improve the speed a little bit. And if you don't care about the order in which you go through the loop, then you can actually do it backwards and remove the need for this extra variable completely. So we go var x equals the data length, and then whilst x minus minus, do something. And of course, that's naturally going to terminate when it goes down to 0 because it goes to false. So that's quite cool. Sorry, any questions before I jump on there? Is that yes? So, efficient looping. Don't use for each. In pretty much all browsers, it's up to 85% slower, which is not a bad thing. Sorry?
And why it was added to the ECMAScript specification?
I don't know.
A couple of days.
Not unsure on that one, but basically, let's use the ones that are fastest for now, definitely. Define local variables for frequency reference objects, even properties of objects, even array lengths, and so on and so forth. Cache them if you can. Which brings me on to minimizing chain length. So what I mean by chain length is when you've got an object and you're accessing some properties, then another property, and then its value. Each time you go deeper and deeper into the object, it gets slower and slower to access. Well, in most browsers. So this is one example where Chrome is doing very well. So let's have a look at this. So Chrome is pretty much consistent on the bottom, so you don't need to worry there. But most other browsers, especially I think that's IE at the top maybe, probably, yeah, Internet Explorer 7. Once you're going 2 or 3 levels deep, you're getting like 120 milliseconds of lag in your loop. And this is over like many reads. But if you're doing some complex particle kind of animation, then you're going to easily hit 200,000 reads very, very quickly. So watch out for that. And also avoid DOM manipulation whenever you can. So does anyone know about reflows and repainting? Yeah, there's a few more people interested in that, good stuff. We'll come on to that on the next slide. So, now, why are DOM operations expensive? Basically, when you perform a reflow or a recalculation, a repage, sorry, the browser has to redraw everything in the window. So let's say we had a paragraph, and we then display none in that paragraph, so it disappears. Now, all the other elements are going to be shifted up at that point, so the browser has to recalculate the position of every single element, okay? And that takes a non-trivial amount of time, especially on pages with a very large DOM structure. So typically, you might write something like this. So you have an unordered list, you get a reference about an unordered list, and let's say you want to add 10 list items to this unordered list, okay? So here's my nice efficient while loop going backwards just for fun. And you typically go document.createElement li, so you're creating a list item. It's setting the text to be test, and when we set the text there, when we add it to the UL append child, we're causing 10 reflows at that stage throughout the course of the loop. Okay? And then, we're going to set the style as well. We're going to set the width to 100 pixels. And every time we change the style, we're causing a reflow. So over the course of the loop, that's another 10 reflows. So in order to make this content, we've made 20 reflows on the page, which is really, really expensive. And notice that before the loop can progress, because JavaScript is not parallel, it's got to do that work before it continues to the next line of code. So you're slowing the loop down as well, which is not very good. So the better way to do this is to use create document fragment. I'm always surprised how few people actually know of its existence, but it's very, very powerful. So let's have a look at this. All this does is create document fragment. It's like the DOM, but it's an invisible DOM. So it's just in JavaScript memory, if you will. But you can treat it like the DOM. You can add to it. You can set styles and manipulate it like you would normally. But nothing is ever painted to the page at this point. Okay. So let's do this. So on the second line here, we create a frag variable, and this is simply document.create document fragment. Okay. Now instead of appending child to the DOM, we append it to the frag element. And now, when I set the style as well afterwards, 0 reflows have occurred previously. Nothing's been added. So no reflows. And then at the end of the loop, outside of it in fact, I then append the fragment to the unordered list. And that causes only 1 reflow. So this is, well, almost 20 times faster, which is very, very good. And one thing to note here is that when you've got existing DOM nodes on the HTML page, and you want to change it, change the CSS class rather than each style individually, because every time you change a style, that's a reflow. If you change a class, that's 1 reflow, but you can have many styles in that class. So that's much more efficient as well. So, what's wrong with this code? A little test for you all. The top, I tell you what I'm trying to do potentially. So basically, I'm trying to get all the divs on a page, and I'm trying to then double the amount of divs on a page. Don't ask why, it's a silly example, but that's what I'm trying to do. But this won't work. Can anyone tell me what's going to happen if I execute this?
It's not defined.
Sorry?
It's not defined. Because this is not an array, it's an HTML collection.
So basically, okay. This returns an array. This one here.
Not an HTML.
Oh, okay, this collection, sorry, yes.
So
ignoring the length, assuming it's an array. Sorry?
It will add 1 element.
No.
No?
No. A few more guesses and then I'll give away the answer.
It would be just so much so than adding all the divs at
Sorry,
once.
can't hear what you said.
I say that it will be much so than adding all the divs at once.
All at once.
Divs, not discriminating divs.
Oh yeah, it's live collection.
Yes, it's a live. Very good. So basically, this is an infinite loop. Because we've got a reference here to divs.length. Every time we add a div to the page, the length is going to increment by 1, which means we never ever get to the end of it, which goes on forever. So instead of adding 1, it goes on forever, and you get a memory error or something like this.
You should say divs length to the private array.
Sorry? Yes, correct. So it's exactly what I did here. And the correct way to do it is, as you said, store the cache event in a private variable and then use that cached version to perform the operation. Cool. So we're going to round up with some look into the future. Now this is heavily Chrome based, but I see a lot of this stuff kind of coming to other browsers over the course of a year or so on and so forth. The first thing is Css Filters, and it allows you to do Photoshop-like filtering on your images, which is quite cool. So in the top left, you've got my original image, and just to prove that this image over here, which is black and white, is the same, but over in the new tab, that is the same image, okay? And these are quite very fast to do, and combine black and white, sepia effects, and hue rotations, invert, contrast, and even combine them together to get really crazy looking things. So that's worth noting. And the way we can do that, if I just jump into the code and inspect the elements, you can see here, it's really simple. Webkin filter, invert 100%, hue rotate 170 degrees. So I can just change that. And you can see the hue is now changing on the screen as well. So you can cycle through whatever colour we want, which is quite powerful. And it's very, very fast and really easy to do, so that's cool. Next thing is the page visibility API. Easy way to show you this is just to demo it. So we've got the video playing on a page, very nice. And then I go to another tab. Notice at the top to the left there, it's paused itself for 3 seconds. It knows that we're not looking at it anymore, which is quite useful. And if we go back to it, it starts playing again, which is quite nice.
Yes. As far as I understand, it doesn't work when you switch to another application.
Correct. It's only when you're in another tab.
So it's not really that useful.
It depends on what you're trying to achieve. And in some contexts, it's nice to know that they're in another tab. If you launch another window or so on and so forth, it could be useful in some instances. Maybe it would be nice if it knew if it's different. It's better than nothing. Correct. Next one, speech API. I assume this laptop has a microphone. I should try it. Hello, everybody. Oh, no, it doesn't have a microphone. Okay. Well, basically, if I said that, it would go into the box if I had a microphone on the laptop, and it would then print itself. You've seen this before, I'm sure. However, in Chrome 25, I believe. Is this video? Okay.
Hi, I'm Glenn Shires, engineer at Google, and I'd like to show you the new speech recognition feature that we've built into the Chrome browser. With the new web speech API, developers can make their web pages recognize what you say. For example, this demonstration page allows me to speak a message and then send it directly to an email application. To start, I click the microphone and begin speaking. Chrome keeps getting better. New paragraph. Hi Dad, comma. Web pages can come alive, period. I'm composing this email simply by speaking, period. Now, I have no excuse to not write to you more often, exclamation mark. When I click the Create Email button, it opens up my default email application, and I'm ready to address and send it. With the new Web Speech API, developers can add speech input to their websites.
So, I mean, the key difference here between what this guy was talking about and the one that's in his presentation is that the one in the presentation, you can only change a couple of words before it starts to fail. So they've really improved it drastically to handle long dictations, which is quite cool. And that's currently available in Chrome 25, and I'm sure other browsers are going to start implementing speech, W3C speech API as well. On my next slide, audio. Sorry.
One question regarding the speech API. Does it differ from the API in Android? Because in Android we also have speech recognition.
Sure. So this one is, well, the one I've just demoed is the one recommended by the W3C. So it's got its own API, which has been, well, if you look online, you can see it's called specification. So it's a common one for all platforms.
Okay.
Yeah. Audio. So we saw some very basic audio demos at the beginning of the presentation. but it can do much more fancy things, such as cross-fading. So you've got some organs on the right-hand side, and as I left in, you get the drops as well. So that's quite powerful, so it's quite cool. So you can be your own DJ effectively, which is quite nice. But you can also play with frequency manipulations. You can cut off the bass and get the treble, the starts and music, take the quality up, and then take the frequency down. But yeah, it's very, very powerful. And you can get really good control over the audio with HTML5. And I put a link on the slides here for the demos and source code and how this was made. It deserves its own presentation, really. I don't have time to go into it all right now, but the link has all the details you could want on this if you want to make it yourself. Finally, accessing the webcam. A lot of people ask me, is this possible? And yes, it is. Unfortunately, sound is taking audio from the webcam isn't possible at present, but there is plans to support this in the future. Now, this laptop appears to have a webcam. Let's see if this works. Okay, cool. So you can see me live in this room. And one thing to note here is don't forget you can add all the CSS filters that we saw earlier to this as well. So the key thing here is combining all the knowledge you've learned today to make really powerful effects like this in your own applications. And with that, I think that's the end. So feel free to add to Google Plus and Twitter. Thank you for listening. And if you have any questions, I'll be around afterwards in the break. So thank you very much. Cheers.